We're going to look at something called the law of sines. And what the law of sines allows you to do is to solve pieces of triangles that are unknown. So if you have a triangle and you know one of your sides here, you know the angle across from it, and let's say you know one more piece of information about the triangle. Let's say one more side. If you knew that much, you would be able to use the law of sines to figure out the other angle across from that side that you know. And with that information, you could figure out another angle, and with law of sines again, you could go back and figure out a missing side. So law of sines can help you find missing angles or missing sides of a triangle. And we'll look at exactly which ones it can and cannot do. But to start out, there's a basic pattern or formula, and that is that you take the sine of an angle, and sine is usually written sin, of some angle divided by the opposite side. So we will put side. So sine of the angle over its opposite side is equal to sine of, let's say, a different angle, call it angle 2, over another side. So any sine of one angle divided by its opposite sides will equal the sine of a different angle divided by its opposite side. And now let's get this in a form that you'll probably want to write down. So this part here you might not need to write down. If we have an example triangle, let's do that one right here. Let's label the corners, the angles A, B, and C. Now A, B, and C are all angles. I'll even put a little angle sign if it helps you remember that those are angles. Then you have the sides, and the sides opposite the angle get that name. So this is side A because it's across from angle A. Then side B is across from angle B, C is across from C. Now it doesn't matter which one is which. Any ABC pairs work out as long as they are across from each other. The C is across from the C, the B is across from the B, and so forth. So now the formula, the way it's typically written, is going to be sine of A over little a is equal to sine of B over little b. So sine of A over little a equals sine of B over little b. And you could also say that it is equal to sine of C over little c. Now when you are actually using this in a problem to solve something, you might only need part of it. So let's say you don't need A, you don't know anything about A, but you know B and C. So you could use those, or you could use A and B, or A and C. It doesn't matter which part you use. This is true that all of the ratios of sines of angles to the opposite sides are going to be equal to each other. Let's start out here with number 7. We need to find angle S. Right there, we need to find that angle. Now we know with the law of sines that it is always going to be opposite pairs that we are interested in. So we want an angle and a side. So here we have a side and an angle that are opposite each other. And then we need another side and another angle that are opposite each other. So here we have side length of 20 and angle S. Now, of the two pairs, of the 4 pieces of information, we know 3 of the 4, which means we have one angle S. We'll even put a little angle sign there. Angle S, which is still unknown. So angle S is unknown. We know the 2 side lengths and the other angle. So we can use law of sines to help us. So we can write sine of our angle, 127 degrees, divided by our side length, 34 centimeters, is equal to the sine of our angle, I always take sines of angles, so sine of S over 20. Now you might notice here that I don't use A, B, and C. You don't need to necessarily relabel it as long as you know that you're using opposite pairs. It doesn't matter what they're called. Once you have this set up, There's a few different ways to go ahead and get sine of s by itself, but the easiest one that will work in all situations is to cross multiply. So if you take the sine of 127 up here and 20 down here and you multiply them by each other, you're going to get 20 times sine of 127. And that's equal to 34 times sine of s. I always recommend writing the number part first and the sine second. There's just a lower chance of making mistakes, especially when you use your calculator if you write it in that order. So put your number parts first. Now your goal here is to get s alone. You want to solve for s. S is unfortunately bound up in this sine function here. Now sine is not a number. You cannot divide sine away. So don't try to divide both sides by sin, because that is not a number. You cannot do that. It'd be like dividing by multiplication sign. You can't divide this side by the multiplication sign to get rid of the multiplication sign. Sine is actually a function or an operation in itself. What we can do, however, though, is start out by getting sine of s alone. So let's divide out the 34 from both sides. And when we do that, they will cancel, because this is multiplication here, so we can cancel top to bottom of those 34s. Now we have sine of s alone on this side, and I'll just clear this out to make that clearer. So sine of s is alone. If you want to undo a sign, get something free from a sign, you need to take what's called the inverse sign. In the same way that we undo multiplication by using division, we undo a sign with an inverse sign. And that is written as sine negative 1, or on some places you might see it as a sine or arc sine. So we're going to take the sine negative 1 of both entire sides. On the right side here, the inverse sine of the sine of s is just going to be s. So these nicely cancel each other out, leaving us with just s. Over here, we have a sine on the outside, we have a sine on the inside. Those will not cancel. The reason they will not cancel is because of all of the other things around it. You're not taking the inverse sine of just the sine, you're taking it of that 20 and that 34 as well. So don't try to cancel out these signs here, because that is also illegal. It'd be like canceling through addition in a fraction, which we know is illegal. So now you type this into your calculator in a single shot. You would do, on most calculators there's a button, the second key, and then you would push the sine key. So you do second sine, and that on most calculators will give you this inverse sine right here. It gives you an open parenthesis. You can type in 20 times, and then you do just the sine button, not the inverse sine this time, just the regular sine. Type in 127. On most calculators, you'll need to close your parenthesis here for the sine, because sine will be written as sine with an open paren, so you need to close that so that it calculates everything right. Then once you have that, you do divided by 34, because remember, a fraction bar is just a division sign, so divided by 34. Close your final parenthesis that was started by the sine inverse, hit enter, and you should get something that is approximately 28.0. We're rounding to the nearest tenth, so 28.0 is going to be our answer. And now we need to think of what are our units. We were finding an angle. We are finding angle S. So our units on this is going to be the measure of the angles, which is in degrees. So our answer for angle S is 28.0 degrees. We're going to skip down to number 12 now, and we are told to solve each triangle and then round our answers to the nearest tenth. Now when you're asked to solve a triangle, you are asked to find everything that is unknown. We know this side, we know this angle, we know this angle. We do not know this side, we do not know this side, and we do not know this angle. So we have three things that we do know. Three things that we do not know in this triangle that we need to figure out. Whenever you are given two angles and a side, we are thinking, okay, we might be able to use law of sines. But if we look for an opposite pair, 42 is across from D, 36 is across from an unknown side, and 30 is across from an unknown side. So we are out of luck. There's nothing, no pairs that we can set up with law of sines. Conveniently though, we do have a triangle, and we know that the angles of a triangle add up to 180. So we can take 180, subtract away 30, subtract away 36, and we're going to get our last remaining angle, angle D, right there. And angle D then will equal, if that's 66, this is going to be 114 degrees. So we get 114 degrees for D. Now we need to do our opposite pairs, because we do have this and this across from each other. And so we can use law of sines. And we can say that the sine of 114 degrees over the side length of 42 is equal to any other pair that we choose. Now, it doesn't matter if we start with this side or this side, so I'm just going to pick this one, the DE side. We have a 36 across from an unknown side length. So sine of the angle, I did the angle on top on the left, I'm going to do the angle on top over here on the right. Sine of 36 degrees over our unknown side. And I'm going to call that side little f because it is across from angle F, the big F. Second step, I cross multiply. So I have 42 times my sine 36, so going across, 42 times sine of 36 degrees equals f times sine of 114 degrees. Now in this problem, we're trying to get our unknown thing f alone, and f is not trapped inside of anything, so we can actually divide both sides by the entire quantity sine of 114 degrees. You'll remember earlier I said you cannot divide by sine. That means you cannot divide by sin alone. That would be like dividing by the multiplication sign. But dividing by sine of 114, sine of 114 is actually a number. If you type sine of 114 into your calculator, it would give you an answer. So you can divide by sine of 114. And we need to do that on both sides since it's an equivalent problem here. And by doing that, we're going to cancel out the entire sine of 114 on top and bottom on the right. On the left side, nothing will cancel out, but we do now have f alone. So we can go straight into typing this into our calculator here, and when we do that, our calculator is going to give us back approximately 27.0. Again, we're rounding to the nearest tenth, so 27.0. And it is a side length here, so it looks like we don't have any units on our length, but it is not degrees. Please do not put a degree symbol on that 27. It is a length. Now, we are solving this triangle, so we are not done yet. We have one more step. We have a missing side length over here, and that's across from angle E, which is 30 degrees. So we need to do law of sines one more time. And this time when we do it, I would always use your original pair that you found, this case the 42 and the 114, with our new pair, the 30 degrees and the unknown. Reason you always go back to the original instead of using your new pair of 36 degrees and 27 is that you rounded on that 27.0. The 114 and 42 are exact, so you don't want your rounding error to build up. So let's go ahead and set up our new fraction. We have sine of our original thing, 114 degrees, over the original side, 42, equal to the sine of our new angle, 30 degrees. That's this one here. And our unknown side, which is across from that little e. So side E. We cross multiply here, and we get 42 sine 30 is equal to E times sine of 114 degrees. We want to get E alone, so we divide both sides by sine of 114. And doing that will cancel those out on the right side, leaving just E. So on the left side, we need to type that all into our calculators. So we do 42 sine 30, close our parenthesis, divided by sine of 114. And that will give us 22.987. We round that to the nearest tenth, and that's going to be about 23.0. So on our diagram, we can put that in 23.0. Again, it's a side length, not in degrees, so we do not put a degree symbol there. If we want to clean up our picture a little bit here, we can do that. But our final answer is going to be all the things that we marked on here, the 114 degrees, the 27.0, and the 23.0.